Research terminology. The first term that is important to understand in evaluating the scientific literature is that of the hypothesis. A hypothesis is a statement that predicts relationships between independent and dependent variables. So essentially you look at your outcome measure and you manipulate certain variables within the study to see what happens to that outcome measure. And we'll talk a little bit more about what independent and dependent variables are a little bit later in this lecture. So as an example, and this is a really crude example, you're always going to have two statements in a research project. The first of which is the null hypothesis, or H sub naught. And in this example, we're stating that there is not a relationship between gender and activity preference. Now, once you collect your data and you test this hypothesis, you either can fail to reject HO, and so that is you didn't find any data to suggest otherwise, and you're saying that any difference that you find is due to chance. Remember, we're talking about statistics here and probability when we analyze data. So any differences that might occur in a research study where you fail to reject HO means that they're basically up to chance. They just happened. There's no explanation or relationship between the variables you're looking at. Now, the second statement that you're going to have is the alternate hypothesis, and this is H1. And in this hypothesis, you're saying that there is a relationship between gender and activity preference. And once again, if you, let's say, do this research study, collect data, and you find that you have to reject HO because of the statistics, then you accept H1. So here you're saying that there is a relationship between gender and activity preference. Another term that's important is theory. A theory is a much larger, overarching relationship that tries to explain the cause and effect among variables. You help to explain and predict phenomena. And usually this comes about from many hundreds of studies that look at small pieces of the puzzle and puts it together as this larger theory. So you do a lot of hypothesis testing and then come up with all the pieces of the puzzle, put it together, and you create what's known as a theory. So you're trying to organize all of the data that's been published in a particular area. Whereas a law is a little bit different in that, unlike theory, it has absolute consistency in the outcome measures. So you know exactly what's going to happen to a particular variable if you give a treatment or manipulate a particular variable in a certain way. So a law is much more concrete in science, whereas a theory is continually evolving based on the available data, which sometimes can present problems for people who aren't scientists and are looking at it from the outside in, and who see scientists basically, arguing back and forth whether their hypothesis is correct versus another hypothesis. And that's part of science, is that you kind of go back and forth until you find this middle ground, or so to speak, where the barometer points based on all the literature that's out there. So a law is much more concrete, and a great example of this is the Earth revolving around the sun in the solar system. We know that. That is a law. It's not theory. You're really not going to find any other hypothesis that will otherwise contradict that particular law. Another thing that we need to consider is the population as a whole. So if we look at the United States population versus the sample population. So the sample population is just a group of individuals that you've used in your research project. And hopefully that sample is representative of the population as a whole. More often than not, it's not. So we need to take a look at this and see what the results that were found, what population are they applicable to? One of the best examples of this is really looking at ethnicities and races. A lot of times studies are done in one particular on one particular race, and then those results are they're applied to other individuals, and we have to be careful with that because we know that there are differences that exist there, and it may not correspond with that particular population. So having a sample population that's representative of the population as a whole is very, very important in research, and that's something that you want to be aware of when you're reading your research articles. Along the lines of sampling populations, there are a few different ways you can do this. One is by use of a convenience sample, and you essentially recruit subjects that are easy to survey. So maybe you walk into a nursing home and you have a questionnaire that's geared towards seniors. Well, that's a convenient sample because they're in a nursing home and you've got a bunch of seniors living there, so you can get that information quite easily. That's a little bit different than a random sample where you are putting out the message that you've got a research project going on and you need individuals to participate in your research project. So that is hopefully a random selection of the population where you're getting a variety of different people rather than the convenience sample, which has its benefits as well. So it's not that these things are good or bad, it's just that this is something that you want to consider when you're looking at your research studies that you're looking at. One thing to note about random sampling is that it's not random assignment. Random assignment is trying to evenly distribute your participants among whatever groups so that they're equal to begin with at the start of the study. I'm going to discuss that in another lecture that relates to internal validity. So let's talk about the independent and dependent variables. The independent variable is the variable that is going to affect another variable. It's the one variable that you're manipulating to basically affect an outcome. So, for example, if you're administering a dietary supplement, the amount of that supplement is the variable that the experimenter is controlling that is going to affect whatever outcome measure that you are measuring. And speaking of measuring and outcome measures, the variable that you're measuring is what we call the dependent variable. It's affected by the independent variable. So this is the variable that you're actually measuring. So if you're looking at administering amino acids to a group of individuals and you want to see if they get increases in muscle mass, the muscle mass is the variable that is the dependent variable. That's what you're measuring, whereas the amount of amino acids would be the independent variable. So the dependent variable is dependent on the presence or absence of the independent variable. So let's take a look at some examples of utilizing these terms. So these box plots are classic in research design. And in this box plot that I'm laying out for you here, we're looking at a group of individuals, two groups of individuals actually, one that gets aspirin, one that does not. We're looking at baseline measures here where they don't have any myocardial infarction, so you've selected a group of people who have never had a heart attack, and then you measure them, let's say a year later, 2 years later down the road for any heart attacks. So have they had a myocardial infarction? In this case, we're looking at the incidence, which is the rate of development of disease. So what's the independent variable here? The independent variable is whether or not they get aspirin. What's the dependent variable? Whether or not they get a heart attack. Okay, so you're measuring the incidence of a myocardial infarction. That's the dependent variable, and the independent variable is what you control. That is the amount of aspirin versus no aspirin. Another example, if we have a sample population here of 200 people and we're looking at vitamin C intake, and 4 months later we're looking at the number of colds and trying to relate that to vitamin C. What's the independent variable here? The independent variable is time, and that is you're looking at a period of time 4 months later as far as their vitamin C intake is concerned. What's the dependent variable? You're basically looking at the number of colds that these folks get based on what their vitamin C intake was. Another word that is important that you see quite often in the literature is prevalence. Prevalence is the current rate of a disease. It's a snapshot of what's going on. You either can look at this using whole populations or a subgroup of population, that sample population that we were talking about earlier. So it's the number of persons with the disease per the number in the population. So how many people have the disease today? So in this example, this is a research study looking at vitamin E intake and how many people have cardiovascular disease. And we've separated the vitamin E intake into low, medium, and high. The independent variable here is the vitamin E intake, and you've separated them out into 3 groups. The dependent variable here is measuring the number of individuals who have cardiovascular disease. The next term that's important that you'll see quite a bit, and I've used previously, is incidence. This is the development rate of a disease or variable of interest within a group over a defined period of time. So it's rate over time. It's number of persons developing a disease per the number at risk per that given time period. So as an example here, we're going to use vitamin E intake again and cardiovascular disease. And so we've got 3 groups here of vitamin E intake, low, medium, and high. We have baseline measures here, the pre, measuring the vitamin E intake and making sure that none of those individuals have cardiovascular disease. We measure these folks 10 years later, and we determine how many of them developed cardiovascular disease. That's the incidence. What was the rate? So this tells us the rate of development over a period of time. In this case, it was 10 years. Okay, so other terms that are important here. The control group versus the experimental or treatment group. This is really important. So let me use this as an example here. We've got a shake that includes some whey protein, and those groups got the whey protein, and there was another group that didn't get any whey protein. And basically at baseline, we're looking at their lean body mass, that's the LBM, and the amount of weight training they do. And we follow them for the course of a period of time while they're ingesting or not ingesting the whey protein, and we look at the amount of muscle hypertrophy. So in this instance, we have a control group, which is the group at the bottom here that did not ingest the whey protein. However, they did ingest some kind of beverage that included apparently some skim milk here, peanut butter, and chocolate syrup. So they did receive those aspects, but they did not receive the whey protein. So it's important to have this control group because in a research study, sometimes you get individuals who will actually, you'll see improvements. There'll be a placebo effect, but yet they didn't receive a treatment. So in order to be able to determine whether or not there was a real treatment effect from the experimental part of the project, so in this instance, the folks who got the whey protein, in order to determine that that's in fact any muscle hypertrophy that they got or that you saw or observed in the study, it was because of the whey protein. You have to have a control group that basically says, hey, look, the control group didn't change, but we saw a change in the whey protein group. Then you're able to decide whether or not that was a placebo effect or whether there's something real there. So it's important to have that control group in a research study. It's also important to blind the participants, especially in something like this where they're receiving some sort of treatment like whey protein. You want to make sure that they don't know what group they're in because that can actually affect the results of the study. They might try harder to increase muscle hypertrophy. Maybe they'll, train harder than they normally do because they know they're getting the whey protein. It's also important that the researcher, again, particularly in something like this, does not know what group of individuals are a part of the whey protein or are not receiving the whey protein, because researchers can also introduce their bias and perhaps treat people differently in the research study. So we want to be careful of this too and ensure that the studies are double-blinded, not just single-blinded. Another term that's important that you'll see in the literature is that of reliability or precision. This is the reproducibility of results. So whether it be conditions, behavior, instruments, we want to be able to use a particular tool. In this example, we're looking at vitamin D for measuring the rickets incidence. We want to make sure that whatever tool that we're measuring to measure the incidence of rickets, that it's reliable and it's precise, that it's reproducible each and every time. Along those same lines, validity or accuracy. We want to make sure that the test that we're using to measure, and again in this example, rickets, that it's able to actually measure what we want it to measure. So the test measures what it intends to measure. If the tool that you're using isn't very accurate, so in other words, it's got a large standard deviation and doesn't really measure what you're looking for, then your results aren't going to be all that great. So that's an important consideration when you're critiquing research articles as well. Empirical evidence, empirical observations. The power of observation cannot be understated. It's so important that we observe and be bystanders in these research projects so that we are seeing the results, what's going on. And that's the best position to be in rather than trying to introduce bias and treating situations differently. So we just want the facts. That's what we're trying to get. We're trying to get the facts to understand what's going on. The important thing about studies that are completely empirical based, a lot of epidemiological work is like this, is that it doesn't answer the questions when, how, or why. The randomized clinical trial is really designed to do that. And again, all types of studies, whether it be epidemiological or randomized clinical trial, there's all their advantages and disadvantages to those research studies. So we want to make sure that when we're reading the literature, we understand what kind of research project this was. Okay, and the last thing that's important, anytime you're dealing with human subjects, the study always has to be approved by what's called the Institutional Review Board. And this is a board that looks at the research design and what you're trying to do with your variables and your research subjects so that you're not going to put the subjects or participants in undue harm, unnecessary harm. And so that's a really important part of the process. And when you're looking at the research articles, you should always see that statement in there somewhere that that particular study was approved by the Institutional Review Board. One of the things that you'll see in a research study, not necessarily published, but is that the informed consent form was completed. And this is a statement that has to include the purpose of the study, the procedures of the study, what are the risks and discomforts to the participant, what are the benefits from being a part of this study, are there any alternatives to participation? In other words, are you forcing these folks to participate in this research project? We want to make sure that the information that's collected about people is confidential and that you're not going to share names and addresses and phone numbers and all that kind of stuff with everyone. And if the participants have more questions, can they request more information? Can they refuse or withdraw from the study at any time? These are important concepts. There should be, an injury statement. Hey, is there any risk to me? And if I do get injured, how are you going to mitigate my injury? Are you going to, provide treatment, or are you going to call for help? How's this going to work? The consent statement that clearly states, hey, I understand what I'm getting myself into, and I acknowledge that there are some risks. Let me go ahead and sign it. So the participant is going to have an area where they're going to sign it. If they're a minor, then they need a parent or guardian. And then, of course, the witness, usually one of the research heads or students and graduate assistant or something like that, is witnessing the signature. So that's an important piece that you won't normally see out in a published scientific journal. However, usually there's a statement in there that says that people voluntarily participated and signed an informed consent form. That's something that you want to look out for as well, for the protection of human subjects.